Hello everyone. Today we are going to discuss another power system concept, circuit breaker. What do you mean by circuit breaker? Circuit breaker is basically a switch which isolate healthy part to the faulty part. Basically, if there is a fault will be there, so very high amount of current will flow through that one. So that if high current will be going through any device like that, if one device is having fault, so that device is already finished, that was destroyed, but due to that one, every instrument, every electronic instrument will suffer, because if high current will flow through that thing, so another instruments are also in damage, in serious condition. So maybe it will burn, or any other mishappening will happen. So that's why we are, if near every element, we are connecting a circuit breaker. It is like a fuse. If high current will be there, the fuse automatically blow, means it will that fuse will cut off. Similarly, it is a circuit breaker. Circuit breaker is a switch. It will be off like that. It's just like fuse, but it's advanced than switch. Okay. In fuse we have to again we have to connect that thing. But in circuit breaker, if situation will be normal, automatically it saved that thing, save, and it will connect by themselves. That the thing of circuit breaker. Basically, what will happen? What the concept is? We are connecting a very high resistance, very high resistance. So, if whole current will flow through high resistance, then resistance will oppose the high current. So, the damage will be lesser, or it can be protected. That's why we are using this thing. So there is some concept in a circuit breaker. Some problem will ask. So first thing is restriking voltage. See, this one is a resistance, a inductance will be there. This one is a capacitance between two line. One capacitance will be there. Any system there should be, if everything in a fan and everything, capacitance will be there. If a system, electronic system will be present, or electrical system will be present, that made up of resistance, inductance and capacitance. Capacitance may be very very small, but it will present, definitely present. If it is very very small, we can neglect that thing. And across that, E is a supply power. So then it is connected to a circuit breaker. Okay, this one is circuit breaker. See, this circuit breaker is there. We are grounded that thing. Every system should be grounded. So in case of high current, it will go through ground. If any system anywhere, we are grounding, it's very very important. So here a fault, this sign is for fault. If fault will be there, high current will flow through, circuit breaker will open, so this system will be isolated from this thing. So what is V? V equal to E 1 minus cos 1 by root LCT. So where L and C are inductance and capacitance per phase of the system up to the point of circuit breaker location, E equal to system voltage at the instant of arc interruption, and V equal to restriking voltage. V equal to restriking voltage. Here we are reading about V. So how we will calculate V? V restriking voltage equal to the supply voltage E into 1 minus cos 1 by root over LCT. This formula you have to remember. The maximum value of restriking voltage equal to 2 into E peak. Okay, where E peak equal to peak value of the system voltage. Natural frequency of oscillation equal to Fn equal to 1 by 2 pi root over LC. Rate of rising of restriking voltage triple RV equal to Wn E sin omega nt. The maximum value of triple RV equal to omega n E peak. Another concept is resistance switching. Frequency of damped oscillation we have to find out. See here L, C and E is there. Here R is connected this way. So this is IR, this is circuit breaker, and fold will happen. In this time, frequency equal to 1 by 2 pi root over 1 by LC minus 1 by 4 RC R square C square. One series resonance, another is parallel resonance. We are working. Here we can find out resistance switching. Previously we can find a restriking voltage in that way. Okay. Note, if the value of the resistance connected across the contact of the circuit breaker, it is equal to or less than 1 by 2 root over L by C, then there will be no transient oscillation. See, here one concept is there, transient oscillation for different values of R equal to, see, this one, first point, if R equal to infinity, voltage across the gap. Second point is, if R greater than 1 by 2 root over L by C, here R less than 1 by 2 root over L by C. Transient oscillation for different values of R, we will find out. If R greater than 1 by 2 root over LC, okay, there will be oscillation. If R equal to 1 by 2 root over L by C, it is known as critical resistance. There will be no oscillation. So we have to maintain at least 1 by 2 root by LC resistance value. Above that system will be in oscillation and it is not suitable, and it is very dangerous. Oscillation is very dangerous for our system, and the products or that instrument may damage. So we have to remember every time we have to achieve critical resistance through inductance, so then there will be no resistance. If less than, it will be okay. R less than 1 by 2 root by LC, it's okay, but we have to see R equal to 1 by 2 root by LC, it is known as critical resistance. This thing is very important. We have to find out what do you mean by critical resistance. That will ask, find out critical resistance, and it will give inductance and capacitance. Then we will give R equal to 1 by 2 root by LC. Bye bye. This is for circuit breaker. We will see in another class.